Okay, so to kind of close this unit down, we're going to be taking a look at a word problem. It's pretty challenging in terms of the way that we got to think about it. It's kind of like two questions in one, but if you haven't taken a look at it, read it and tried it out, kind of pause the video, try it out, come back with some ideas with it, and then get ready to kind of take a look at a solution. So let's kind of read out this one and let's see what we can make out of it. Danny started his own computer repair business. He offers his customers two payment options. He's got an option A, which has a base fee of $40 plus $8 per hour. And then for the computer repair, he's got an option B for them. There isn't any base fee, but then it costs $15 an hour. How many hours does a repair job have to take in order to make option B to be less expensive? Model the problem using an inequality. What you really got to be aware about in these types of problems is that there are two things going on. There's an A and then there's a B. And you really got to kind of separate your thinking based upon, hey, there's two things going on. There's an option A, and let's leave our thinking for option A over here. And then there's an option B over here as well. And the thing that we don't know in either of these cases is how long it's going to take to do a computer repair. And that should be our variable our unknown variable that we're going to use in this problem. So let's kind of make t equal time for repair. And we're going to do it for both. T is equal for time for repair. Now, I know that the question isn't asking how long it's going to take to do a repair. And the question is actually kind of involving money into this as well. However, we're going to kind of wrap our question around T, and in the end, we're going to be able to solve for it using an inequality for that. So it's going to kind of get to an answer, but it's going to seem like we're kind of working backwards in front of forwards. So let's kind of look at just option A, and let's highlight some important parts about option A. So first off, option A, we have a base fee of $40. Now, base fees just mean that no matter what, even if 0 hours are done to fix your computer, just by Danny laying his eyes on it, he's going to charge you $40. I know it sounds super unfair, but that is basically what a base fee is. It's just to look at the thing, even if it's fixed, not fixed, 1 hour, 2 hour, whatever, it's $40 no matter what, plus some additional stuff. So that's what we're going to kind of take a look at. So he's going to charge, or his price to fix. Let's kind of mold our thinking here. Price to fix. So right off the bat, we're going to have a $40 that no matter what, you're going to have to pay if you want Danny to fix your computer, and you're going with option A. But he's also going to charge $8 per hour. So for every hour that he's fixing his computer, he's going to charge $8. So we're going to attach T to our multiplication of 8 per hour, and we don't know kind of how many hours is going on. Again, if you wanted to, you can certainly make a little table for yourself and say for 0 hours, 1 hour, 2 hour, 3 hour, and this is just kind of like our rough work. It would charge $40, $48, $56, and so forth, okay? It's going up by 8 each time. Plus 8, plus 1. And this is kind of, again, from our linear relations unit that we've done a little bit ago, but it's still kind of showing up here, and that's going to model our equation that we're going to build for option A. We're going to do exactly the same thing, but for option B. Now, option B does not have a base fee, but it costs $15 per hour. So I'll just kind of extend this a little bit more. If you wanted to, go ahead, put a table on yourself for yourself, and 0, 1, 2, 3. He's not going to charge a base fee, so there isn't anything. If he spends 0 hours fixing your computer or whatever, then it's $0. But as soon as the first hour goes by, then it's 15, then it's 30, then it's 45, and you'll see that these numbers are going up by plus 15, and these are going up by plus 1, just like our older unit. So his equation for the price to fix is going to be 15 times t. There's no base fee, but just 15t. Okay, so how many hours does a repair job have to take in order for option B to be less expensive? So what would happen for option B to be less expensive? We really want to figure out what sort of value of t could we have for this inequality to make option B less than option A. Another way to say that is to say option A is greater than option B. Does that kind of make sense in terms of how we're looking at that? So we have a couple methods to do this. We can, first off, just start putting in values of, t in order to see which value of t will it actually begin to be less expensive for option A. That's kind of similar of our table here, okay? And we're kind of matching it in terms of, in terms of the hours spent repairing something for option A to hours spent repairing an option B and looking at the prices. So if we want to figure out how many hours does a repair job have to take in order for option B to be less expensive, let's kind of review a little bit of the hours that it can take here. For 0 hours, $40. For 0 hours, $0. So in order for option B to be less expensive, 0 hours would work. It's not quite a full answer yet, okay? Let's keep on molding this question. Let's keep on kind of going through this one. Let's kind of see for different values here. So we know that for options for $1, or for 0 hours, we would have $40, and we would have $0 for option B. If we kept on going up for t is equal to 1, we would have 48 is greater than 15. So far, option A is winning here. It's going to be, it's more expensive, I should say. But very soon, we're going to see something else happen. 56 is still going to be larger than 2 hours for repair. And we're going to keep on going. 64 is going to be still larger than 45. Add another 8. 72. 72 is going to be larger than 60. Add another 8 here. 80 is larger than 75. And it should be at this stage where we see something happen. Add another 15. And we get something to happen right here. We see that between 0, 1, 2, 3, 4, 5, and 6, between the 5th and 6th hour, it seems that option B is becoming more expensive than option A. So if we're only going to consider whole hours in this question, in which the question doesn't state that we have to do full hours in it, but let's go ahead and say that how many hours does a repair job have to take in order for option B to be less expensive? Well, we would need this question, or we would need to repair a computer for 5 hours or less for option A to be more expensive than option B, or rather saying option B is less expensive. A repair would have to take 5 hours or less to be less expensive if choosing option B. And this is just us kind of going through the list and us seeing, okay, based upon what these values are, what would be less expensive. So all of these hours up to hour 5 and including hour 5, option A is more expensive. So if you knew that your repair is going to take 5 hours or less, you should be going with option B. So we've just kind of answered what this question would be here. We've modeled this equation, but let's kind of go a little bit further in this next video and kind of figure out what the exact time would be. So we've kind of answered this question using whole hours, which is fine, and we can kind of assume that this question is insinuating that with the how many hours, but let's kind of go a little bit further in the next part to figure out, okay, what would the exact hour be?